What's up, guys? It's Daniel Byers. Today I want to put together concepts on solving the 4x4. So when I was looking at my method, I knew that I wanted something that was fast and efficient, and I knew that as I was looking at the possibilities, I realized that if we, rather than trying to think of things in permutations, we want to think about things in possible states, like a combination. And because you want to look at things in pairs and groups and kind of reference things in a different manner than like a commutator. And it allows you to have a little bit more freedom. And I realized that there are some really easy solutions that are kind of implement the concepts of block building to give you a better solution. So what I want to wind up doing, I'm going to wind up doing an L and a wide R, which is going to put these, which is going to build this half bar yellow right here, drop a piece, drop this white piece down, and drop this white piece to here. So I'm actually going to do F prime wide slice L wide R, building this half bar and that half bar. I'm going to do my U to build that one. I'm going to do a triple R, U, wide U, R2, and then a U prime. So then I'm going to do U2 to offset this. That way I do my L prime, wide R prime, another R prime, U. So that way I kick this pair, this half bar in, R2, U. So notice that I was able to do my triggers with U and wide U moves, and so I did my pairing on the LR slice or on the M slice to then, and utilizing the freedom here to be able to finish that up. But let's go ahead and restore that slice U move that I did, kind of talking to that example. So now I want to start building edge pairs and actually really building blocks. So I built the D for my orange yellow pair, and then I glance and I see the blue pair. So I see that I'm here. I'm able to do a slice L2 to pair that up. R prime, U prime, R to build the block, the 1x3, and I have my other edge pair, so I rotate through and connect that pair. So there's a lot of freedom in this step. So I built the first block. I already see my blue pair, so I did the R. I see that I have the 1x1x3. Don't want to, I'm not obligated to do that. Actually, I will go ahead and proceed to probably, I see the other edge pair. I'm gonna actually commit to doing the other pair. So I'm actually, what I'm going to wind up doing is showing you that you can use non-matching blocks just as easily as you can matching blocks. So I have an orange D and a red D for the yellow and the white respectively. So I have my half bar green. One thing, especially if you have non-matching blocks, it may be kind of confusing to figure out what color scheme or what reference you're using. So really, that's the cool thing, is that you can actually do non-matching blocks all together, just kind of disregarding. You can do non-matching blocks and oppositely swap centers. So this pair happens to be right, but it doesn't have to be, because during 4C extended you can actually solve that efficiently either way. So I've got, I solved my first pair to the UB with R, U2, R prime. So now look at my next pairs. I want to try and solve this pair, and I want to try and solve that pair. This pair is bad, and this pair is bad. Excuse me, this pair is good, and this pair is bad. They're opposites, so when I solve this pair is going to be flipped and become good. So L prime, U2, L. And now that I've got two solved in the U, I want to put the third one down, L prime, U2, L again. So I did L prime, U2, L, U2, L prime, U2, L, solving my second and third pair, which gives me two solved pair in the U and one solved pair at the DF. You always either get a false bar and two bow ties, or 3 false bars at this point, and you want to be able to recognize whether or not you have parity. Right now, treating the false bar, you see that the orange is solid, but if you look, it's actually not solved on at the L side of the UL edge. So this is the false bar, and I have 2 good edges, a bad edge, and another good edge. So right now I have 3 good edges, so I have an odd distribution, and now I need to confirm whether that's correct or not. So this pair and this pair, because they're both unsolved, have a common piece, which is the yellow, red, and they are mirrored, so really that negates this, that inverts that. So right now I have a odd distribution, which looks like I have parity, but really because I have my mirror bow tie, that means one of these is twisted as well. So that actually gives me an even distribution. So I don't have parity. So knowing that, what that means is that I can now set up my case so that way I can do a wide soon, L, wide L prime, U2, L, U, L prime, U, wide, L. Finishing up my edge pairing. Now the only other thing is that I gotta do my Nicholas to finish up the cubing, and now I would normally do an L, a slice L to finish up the Nicholas in like pure form, but I'm gonna cancel that out with an R to orient my edges. So then I want to go ahead, do my CMLL. You notice that I don't have parity, and I knew that, and I solved it accordingly. So now I'm here. What I want to do, I have non-matching blocks, and I have also, my centers are good. I don't have parity, so I just did a triple R2 after I solved. I did 4A, 4B, and I came to this case. I was here, and I executed, giving me this state, and I did a triple R2, or yeah, triple R2, yes. So that way that actually rotated, accounting for the M2 and the offset R2 on my non-matching blocks. Cool guys, hope that made sense.